Hi, everyone. Hello. I'm glad to see you here again. And today we have a special guest, Kamilya Altynbekova. She is actually, she is a developer of of that system you are going to see today. And she will, guide you through some internal things which we have in our platform. And the platform is a set of tools which helps you to analyze all these gene regulation data. And and this platform can be operated from very good and easy user interface. And that's what I was always talking during my coffee breaks last few times. And today we will talk about how to use it using API. So if you are here, I guess you know what is API. And I guess Kamilya will tell you more about that. And okay, so Kamilya, the floor is yours. And I'm here on the background to tell you some questions maybe, and to to also to monitor what our guests asking. So please don't hesitate if you have any questions to put it in Q&A section, and I will monitor that. And if there'll be some very urgent questions, we'll interfere and explain it to you. Okay, Kamilya, here you can share, I guess, your screen.
Yeah, thank you. Hello, everyone. So yeah, we're gonna talk about APIs today, and even though maybe you want, maybe you already know something about it, but let me still start from a little introduction to the topic. So we're going to talk about application programming interfaces and what interfaces are available for GeneXplain platform and how can you use it in your analysis. So I will start, with just a little bit of the concept itself. So the API stands for Application Programming Interface, and this is a set of rules, commands that allow several softwares to talk to each other, to communicate. So let's say we have our very useful application. Let's say we have geneXplain platform, and this is a very useful software for your research. It has a lot of features, as Alexander already mentioned, the primary way of accessing and using this software is via the web interface, via your browser. Which is user-friendly and easy to use. But what if you want to use some of the features of geneXplain platform, let's say in your some external software, maybe in your script that you have on your computer or on your server, right? So we do not limit you to just using our web interface. So we have some set of rules, some packages, some commands that allow these two softwares to talk to each other, to share the data, to share the features and functionality. And this comes in form of API. So they can be like some programming languages, libraries for some programming languages, or just some set of rules for HTTP sometimes. So this depends on the form. So we'll discuss what APIs are available for geneXplain platform. But why actually does this exist, right? So why someone might want to use API? So as I said, integrating it into your own script gives you maybe a little bit more flexibility, maybe sometimes to accelerate the process, to automate the processes. If you have like a huge pipeline and maybe a lot of data to analyze, just manually entering all the data into the platform, manually running each workflow or each analysis can be like time consuming. So if you have this issue, API might be a good choice for you just to automate things, to also this is very good for reproducibility, so you can reproduce your results very easily. When you have a script, you can come back to it later, run it. This is like some advantages of using API, and because this is so useful, we offer it in several different ways for our platform. So first of all, we have R programming language library, so geneXplainR. This can be used, as I said, in our scripts, and this can be used in our pipelines. We also have a API for Java, so some Java classes which you can integrate into your Java program. We also have a special JSON interface to also access the geneXplain platform via a command line in maybe your bash scripts and some other external programs. So using all these packages, all these options, you can log in into the platform, upload some data, manipulate the files that you have inside the platform, do some analysis, then download your data from the platform and do like more manipulations that you might need. So more details, we have a dedicated webpage on our geneXplain.com website with the more information about what I'm going to talk. So about each API which is available, where you can find it, some documentation, also some samples, and we also have, you might want to check our YouTube channel where we have also some tutorials on how to use some specific API, specific packages. So today I'm going to focus on geneXplainR package. So I think R is the language that mostly used for data analysis by data scientists, by bioinformaticians. So I would say that many commands and like the logic of how you use the API is similar to like in all these packages. So the same logic is applied. So I think seeing like some examples, demos for one package should still give you a good idea of how to use the other ones as well. I'm going to show some more examples for JSON interface, for instance, or also some more examples rather than what I have in my demo till in the end of this webinar. So stay tuned. We're going to address this also. Some a bit disclaimers before we start. So in order to use the API, as it is often the case with also other APIs, you will need to have an active geneXplain platform account to use it. So before starting to work with the package, you will need to log in first, and that would require username and password. If you don't have it, it's not a problem. You can go and get the free account. And then with the free account, you will also get projects created for you where you can start working. So we will need a valid project where to write your data and from where to download it later. And also, of course, some familiarity with the programming language for which you're going to use the API. So will be R or Java or like command line tools. If you are like very new to the programming and to using APIs, maybe it's good to use it like for some very specific cases. If you are not very comfortable, maybe still use the web interface, which will be easier. But if you're okay with using programming languages, you have some basic understanding of how these programming languages work, then it shouldn't be a problem for you to use our packages as well. Just a little disclaimer, this is important to point out. Also, yeah, so the as I said, we're going to focus on geneXplainR, and this is API for our programming language. Here I also have some links. So the first obvious question, like where to get the package, how to install it first on your system in order to use it. So we have the package available on GitHub. There are some instructions here on how to install it. So if you're, again, a bit familiar with our language, you know that there are like some libraries, and there is this library called DevTools, which allows to install the packages from GitHub. So all you need is just basically those 2 lines of code, just loading the library and then installing from this repository on GitHub. It will be done by our language for you. And once you've run those 2 commands, you will be ready to use the library itself, the API itself. This is just an example of how to log in into the platform, and as I mentioned before, you would need your user and password here. And there is also this documentation for the package with the description of all the commands that you have here to work with the platform. As you can see, it's like the list is not so big. You don't need to memorize like a lot of commands like it's not very complicated to use, and though the commands are very self-explanatory in the in how they are called, I think. So like obvious login, logout, maybe export, import commands, creating folders, projects, some of the very often commonly used workflows and analysis, they have their specific commands to make it easier for you to use. You can also run any analysis or any workflow available in the platform using this general execute workflow or general execute analysis command. So there are also some commands with that just give you information how to use specific analysis, what are parameters. So if you go to some command, you will see like what are the parameters to use, how to write this command. So this, of course, can also be accessed via R. I will show you later. So these are the 2 primary resources you would need to start working with the package. So from here, I wanted to move to the demo. Then we'll actually look at how this works in actual R environment and how this would all like work in real life.
So we are going to real life now, right? So is it only R, or there are other languages which you mentioned Java, right? So and R, that's what we have.
Yes. Yeah, I will also show a little bit how you can later how you can use Python API for bioinformatics.
So Python, stay here.
So there is also Python. I didn't include it like explicitly here because it's more bioinformatics package actually. So our platform is built. The basis of our web platform is bioinformatics platform for bioinformatics research. So this using bioinformatics package for Python, you can also actually access platform via Python script. I will also show example, like not going into very much details, but example of a Python script. And again, as I said, it's very similar, like the commands and the way we interact will be very similar to how our package is done. So shouldn't
Super.
be a problem then to switch to Python if Python is your main language. But mainly, yes, so it's R, Python, Java, and then the JSON interface, which basically will allow you to access platform from any environment, like from most environments. So we'll also see it a bit later.
All right. So now magic begins.
Okay, so now we are moving to the RStudio. This is where I'm going to show the script I prepared, the R script, and we'll try to do like some manipulations to try to use the API package a bit just to show how it actually works on practice. So any script starts with the loading the libraries we have for the that we'll need for our script. Here, again, if you are very familiar with R, these are very famous packages, I think, very commonly used. So the package for data manipulation, the package for visualization, and for working with the tables, with loading data into tables, into R. And a very, very important library for us today, it's the geneXplainR. So I have it already installed on my environment. If you don't have it, just run those two commands I showed you before for the installation. You would need to install it only once, and then once you have it installed in your environment, you just can use the library each time just by calling this command. Here, this is just a command to set my working directory. I have already prepared some examples there. Actually, we are starting with the zero step, as I called it. So the very first thing you would need to do to start working with the API is to log in. So this is our main server under which you probably have account, or you can register and get your account. And then you would need to provide your credentials, so your username and password. Here, I'm already logged in, so I will not rerun those commands to not lose my data, not lose my connection. But also, once you run this command, JX login with the correct credentials, all the other command will start working from this library. And as I said, we have documentation. So if you are stuck at some point, you might access the documentation using this R standard R command with the question mark first, and then you write the name of the command you want to use. And then if you're using RStudio, this will also work in console mode in R. You will also get like some documentation, like some help with the command. So if you are stuck at some point, be free to use this tip to see what you need to do. So then here, so once we are logged in, we can start working with the package. So as I said, it's important to have a project already prepared where you can write data. So for me, I will quickly go. So I will move back and forth from the web interface and my script. Just to show you like what's actually going on into account to see the results here. So I will work with the, I have this project prepared, and so I just copy the path into to this project, and so this is data project and my project name. So this is the path. We need to let know the script where we are working. And once we prepared all this information, let me run this first just quickly. So this with this, I'm having now these variables, having my project path, and here starts the the more interesting part, more useful part, right? So we can actually start doing something. So as you can see right now in the project, I already have some folders which I created before. Let's create a new folder here. So let's say we have our project path, and here you see I created this imports folder before. Let's create like imports too, just to demonstrate. So first I define the folder parse, and then I use geneXcreate folder command, which will create the folder for me under the path which I define here and with the name. So let's create. It will take some time, and then I have here the result that okay, everything seems fine. And we go back and we see that yeah, I actually have a new folder in my account. So instead of course, you can do it here in the web interface with the new folder, but it's also the same thing. You can also add folders with the API. So here, just running these commands, created the folder for us. Now let's add something into this folder. So let's go to the next step, which is a file import, which will be like, I think file import export is one of the most useful commands for which you can use with the API, which you can automate, because sometimes you might have like a lot of samples, a lot of data which you need to upload, and just doing it hand by hand, like manually entering each one, selecting it into the interface. It might not be very convenient. And so you can actually just, okay, let me show you what I have. So I'm actually working, I'm working in this package, in this folder, local folder on my computer, and I have here a bunch of files. Some of them we're going to use today. So for instance, I have this sample FASTA file here. So if we will open it, so it's just a very basic sequence, just some sample sequence I have here. So let's say you have FASTA file and you want to upload into the platform. So I'm first defining this FASTA file. I'm already working in this local folder I'm showing. So otherwise you might need to show like to set the whole path to the local file you have on your system, not just the name but the whole path. But because I'm working in the same folder, I just have here sample FASTA, and then I need to define which file I want to upload under which folder, and what is the format actually. So for the importers, you might check. So we have this geneXimporters command, which just lists here all the files, all the formats which are supported by the platform. As you can see, it's a lot. So we have like very different files you might upload. And just because they are very different, because there's like different parameters that you might want to define for each upload, that's why you also need to like explicitly say it here for the importer to know what you're uploading, how to deal with this file. So in my case, this is FASTA. So if I run this command, then okay, so I see that everything went from 0 to 100%. So seems like everything is okay. Let's check what we have in the platform. Okay, we actually have a sequence uploaded. So this is the sequence. What if you have, let's just look at some other examples. What if you have like web files? This will be read as tracks inside our platform. So I will again show very quickly. So I have here some zipped actually web files. So it's not just web file, but also archived, which I just downloaded from geneXplain Omnibus, I think. So this is like you have some files, right? And they are also archived. So we can also work with the archived files. In the same way you can upload archive into the web interface, you can also import them with the API. So let's see how to do this. Just use the here it's like the general format for all the archives. It will actually work with deep, with like any type, with most type of archives that you might have. So for now here, because I'm using a file from the subfolder, you see I'm actually defining the path here. So what if we want to upload this file? So I first define it, and then let's try to import. Oh, okay, I need it to be that file path actually. So, okay, we are importing, something is running here. It takes some time because this file is bigger than just FASTA. So now we have here a track. But there is one thing. So if you want to open it, it will ask us to provide the sequence source for reference to show the track in genome browser very beautifully. But this is again a manual work, right? So these tracks are actually for mouse. So I would need to like to define the sequence source myself, which is not very convenient. For that, you can check the import parameters, and you see that there's actually like more parameters that you can define. And for instance, there then you might like define more about your tell the system more about the file you have. And skip like more additional manual work. So for instance, here, instead of just saying, okay, I have a zip archive, I also say, okay, so here are my importer parameters, and I actually have bed files inside my archive, and they are also, please select like Ensembl mouse, so please select mouse sequence for reference. And with that, what I also do here, you see that I'm actually doing it now in a loop. So I extended the import command a little bit and also put it into loop to upload all the files that I have under my folder. So here you see I have not one but 6 files, and that won't be very, again, very convenient to write a separate command for each file or try to manually upload each one. So this is the beauty of using the API with and writing your script, because you can automate this thing. So you can just write the for loop and just upload all the files with one command. So I can try to run this loop. So this again, that might take more time, but if you have a lot of files, you just write your script, run it, and then maybe come back later after you have coffee or something, or lunch break, and then your data is already uploaded. So you see that there is the uploading continues here. So we can already go and see. So some files are already uploaded, and if you try to open any of this, oh, okay, let me try again. Okay. Yeah, so you see these tracks, they do not, maybe I'm sorry, maybe I tried to access the track which was still uploading. Okay, so now everything is uploaded. I was too maybe impatient, but if you see now, I do not I'm not asked to to actually add sequencers because it was already defined in the parameters. So now our tracks are already very much usable by the platform. We already know what is the reference for these tracks, and we can already view them or use them as an inputs and so on. So this is just some examples for inverts. Again, we have a lot of formats which we support. So for actually for
Is
my
there,
demo,
Kamilya, just one question, sorry. Is it any limits for the number of files or the size of the files you want to you can import? Just I think there might be some questions like that.
so I think there is I don't think there's like any limitations from the point, like from the API. So it all depends on the on what project you have, like what is the size of your project. So you might want to contact your manager to from our team to see like what is the space available for you in the platform for your account. So this is the limitation, right? So your project size. And for the if you are uploading the data which is still inside the limits of your project to your space, you are free to upload whatever sizes that fits. And this is also again an advantage. So sometimes files like FASTA or FASTQ files, they can be very, very big. So like
exactly, that's
GBs.
Right.
Of data, right? So just waiting for them to import into the platform might also like be not very convenient sometimes. And so this is a good alternative, right? To have a script which will just upload it from your system automatically. That might take time, or again, you also might need to consider your own internet connection limits. So if you,
that's right.
That will then also depend like on your internet connection. If your internet connection is good, if you have enough space in under your project, then you are there are like not any specific limitations other than that.
Exactly. Actually, there is also a question about that in our Q&A. While performing the analysis, do we need to download all the files to our local machine, or can the script extract the archived file directly from the databases like UCSC or SRA, like SRA archives? So that's
okay. So
question, right?
yeah, so there are two ways you can do this. So if you're I'm afraid that for SRA, so what we have the tools here in the platform, which allow to convert SRA format to FASTQ. We also have workflows which work with the SRA files and also help to extract and then automatically do some data preparation for FASTQ, right? So what you can do, you can download the SRA files to your local computer, and in the same way as I just showed the import, so you import them into the platform and then use either those toolkit analysis or workflows or this like SRA to FASTQ workflows to unpack them and already maybe pre-process the FASTQ. So I think it will do some mapping and some quality check analysis.
Right. So, but I guess you can also actually take the files directly from FTP or from the FTP archive. So the question was whether you need to download first these files into your local computer before uploading it to the platform. Okay, you can do it directly from the archive from a database.
I think yes. So we have an import option to import from the FTP. So if you go here to import, you see this web FTP option, from where you just show the URL and upload directly. So no need to have this intermediate step, right? So
can it be done
think,
through the API, or it's probably not? I'm not sure.
yeah, I think, yeah, I'm afraid we might need to in this case we might need to download them.
All right, so
the
through API you
system
can
first.
do it one by one, right? That's true.
Yes. But also again, like there are I'm not sure, but because there might be another tools, like another libraries to also automate like downloading. So because it's a script and you can write the script in whatever way you want, so you might, if you don't want to also like manually download, I think there are some download options that are available for SRR to also just a little automate this step. So to first get them in a more like programmed way onto your system first, and then into the platform. Okay, so for today we are going to use just a tab separated values, just a text file with the raw counts from RNA-seq to as an input to our analysis. So again, I have this file on my system here. So I downloaded 2 files with the raw counts and then with the description of the experiment design. And now I want to upload them into the platform. So I again use the geneXimport command. And this is because this is tabular data. I'm here showing, I selected tabular importer. So let's import the file. So okay, so now we have a file with the raw counts here in the platform. Like you of course don't need to go and check each time. I just want to to show that the things are actually happening, that the commands are working. So we have now the file with the genes and then counts for different samples, and we want to upload. We also have some information about the samples, about the experimental design in the separate file, so we will also upload it. And a good thing is that sometimes our tools on the platform require inputs in specific format, right? So like for instance, I'm going to use a workflow to find differentially expressed genes. So this is the workflow. This workflow estimate differential expressed genes with guided linear model analysis. So here I have like some input. I will need some input table and also some table with the description about samples. So like some metadata, right? And it is expected in some specific format. So also using it, preparing this file in R, sometimes it's faster than using like even our own manipulation tools, data manipulation tools like shaping data, selecting some specific columns and something. So if you're familiar with the with R, with programming language, you might also do it a bit faster with the command. So here I first read the table from my local computer into samples variable, and I can show it. So this is how it's read. So there are a lot of, like, this is a big file with some metadata. I don't need all of this information inside the platform for my analysis. So here I just reshaping and selecting the information I need. So I will not talk about this too much. This is just like using pipe operator of R, and basically what I have now after manipulation, I have the table prepared for the platform with the run with the sample in run column, and then disease here. So you see I have 3 control samples here, and others are actually from breast cancer, and here also some additional clinical term I will need later. So, but for differential express genes, I will just compare those cancer samples with the normal healthy samples. And so now I'm importing this information into the platform as well. And you will see that here I have some additional importer parameters. So what to use as header row. I'm saying that, okay, I have header row, I have column, which I want to use for ID. So this is just like additional things for my importer to correctly read my data. So you see here for ID, I have actually the samples here. So it was run column before, but because I said, okay, use it as an ID, so this is what is used here. So this is just another example of importer parameters. Okay, so once we have the data inside the platform, it's ready. I can use it as an input to our workflow, which I already introduced here. So in order to run workflow or any analysis, you want to know its complete name, which is like a path inside the platform. You might go into the web interface to check like the actual path. If you're not sure, here I'm defining the workflow path first, and then I have also, okay, so because we will need to we'll need like 2 things to launch in a workflow or analysis, is the workflow itself, like the path to workflow, and also the set of parameters for this workflow. And this should also be defined in a R list. So here I have my workflow parameters, and just to make things a bit easier for me, I also define like some parameters as a separate variables here, just to make it a bit cleaner. So I will have the files which I just imported, like the input table with count rows, with row counts, and the metadata, and then I also define the result folder, so where my result of the workflow will be stored. So this is in my project in which I'm working, and then also I give some name because I already have this results. Let's give it like another name. So it will be result 2, and then I can define workflow parameters, and then to actually launch the workflow, this is the command which is used. So this is gx workflow, and this is this takes workflow path as parameter, my list with parameters, and then you might so this is like 2 parameters you might change if you want. So the variables will, if set to true, it will output some information about the progress, like you saw here. And the wait will wait until the analysis finishes, because some analysis might take a lot of time. And if you then your workflow, your like analysis pipeline depends on the results of the workflow, you might set this to true to wait until the analysis actually finishes and then start working with the results. If not, if you, for instance, just launch several analysis and they're not dependent on each other, then you also, like, it's not necessarily to wait for each workflow launch to for each other. So this can be set to false in this case. So if we run it, you'll see, because I have my here it's set to wait and to variables to true, I will have the output here in the console, and we are waiting for the execution of the workflow. And here you'll see that actually, okay, let me close all these tabs. So if you go to interface, you'll see that actually we have the workflow running. So yeah, please ignore these messages. They are just some messages from the scripts we are running inside this big workflow. This the workflow is actually running okay. So we see the progress is going, and you see that I have my table which I uploaded here as an input, and we've selected all the data columns and all the parameters which were selected here. So like the main factor, the reference level, they all are actually here. So it was all set correctly.
So this workflow finally, what is going to give you? So it's at the end, what is calculating and how?
Okay, so in the end, what we're going to have, so now you will see that actually under already in my project, I can see that results are generating here. So the results of this workflow are written here, and then for the I already have one launch that finished before our webinar, and the result of this workflow is differentially express genes. So the raw counts from Rene-seq experiment, they were first normalized. So as you can see from input, we had raw counts here. They were normalized first for each sample, and then the Limma analysis was run to find differential expressed genes between the samples. Because I selected disease as my main factor in my analysis here, so we have we compared the normal, the healthy samples with the ones that have disease. So these samples were compared, and we have here this result. So we have all the log-fold change calculated with the p-value for all the genes from my input, and then some filtering was done to find upregulated and downregulated genes. So we see here, so like around 2,000 genes were selected as significantly up and down regulated. So for those who that log-fold change was the biggest with the best p-value. So this is the result that will be calculated by this workflow. I think I'm going to interrupt just to not waste time here. But yeah, if I wouldn't interrupt, it will just give the same results. So I run this analysis with the same files. So I will just work with the results I generated earlier. And so what I primarily was working with, I wanted to have, maybe you are not very satisfied with the parameters that are already like hard-coded into our workflow to select up-down regulated genes. So you want to work with this whole table here. So what you can also do, so here I did a quick analysis run also. So on this table here, on this result, so you see here breast, you see normal results. So on this table, I used it as an input for analysis. So this time I'm running analysis, not a workflow, which is called annotate table. So this basically just takes table, annotates this in my in my example here, I have just Ensembl gene IDs, and I want to have gene symbol. I will use it later. So I run it with the parameters of annotation by gene symbol and gene description. I run it with this table as an input and got this result. So I got the gene symbol and gene description here. So you see here, instead of workflow, I run analysis, and I now have annotated table, and I can export it. I can export it locally to my computer and do some more manipulation with it. So now I do the next step of file export. So I define a local path. So this is what name I want to give to this file on my local system. It will be like differential express genes result. And let me just have it like these two variables here in my system. And I want to export, so I'm using geneXplain command with the path of the file inside the platform, and with the exported to know what format I'm exporting and the local path where I wanted to store. So if I run it, I will have my differential express genes locally. So let me check the results, which I
all right. So we successfully
exported before. So yeah, so we let's say we exported the results. Yeah, I might. Okay, I think here because I messed up with the result folder, so I rewrite it here, right, to show. Yes, right. So I will just here. So I'm actually using my old results, so that's why I want to. Yeah, so you will need to be very careful with the passes, because this is important to have the same pass, like the correct passes locally and on your project in your project in the platform. So now so now I have all the correct parameters, and I have my you see I was able to actually write this differential express genes results text file. So once we have it, we can do some more operation with it. So I also exported the normalized data here to also do some visualizations. So I have these two files that are results of the workflow. We can read them now, do some manipulation. So here I applied some my parameters for differentially expressed genes to select the workflow change which I want to, and my p-value, and give them like annotation of up and down genes. So this is basically just running some R commands. So this is nothing to do with the API. And we can, using the ggplot R package, we can do some nice visualizations. So that will appear here. So if you, there are some, again, visualization tools inside the platform which you might want to use, but if you want to go and create your own visualizations for your research, like for your paper maybe, then that's like ggplot gives a lot of and bioconductor also gives a lot of commands and a lot of tools to do nice visualizations. So here it's a volcano plot which just visualizes all the genes that were in the experiment and the ones that are were down-regulated or up-regulated, just to show like the distribution in general. What we can also do, as I said, I also downloaded normalized counts, and I can also do some some manipulations with them. So I selected the very top, like I think 10 most up regulated genes and 10 down regulated genes. and I want to also visualize them. Again, there are like, I will not go into detail on the R. This is just R commands, and again, some plot. Here, also like another example of how you can visualize. So this is top significantly differential expressed genes with the names here. So that's why I annotated the genes before to have here nicely gene symbols where it is possible. So and here the normalized counts, just to see like the how some very important genes found in the experiment behave differently in the samples, normal and cancers, and also because we had different clinical information here, we also just visualize it nicely here in R. So as you can see, what we did, we had some data locally, we uploaded into the platform, we did some manipulation in the platform, then got the results locally and analyzed it more and like added some more functionality to the platform. So here again, you can use it for uploading a lot of files together at once and to do like more manipulations, to run more workflows and analysis one by one. I will quickly show another example. So here are some more examples. So here are scripts running inside the Jupyter. So this is also, so here I show the IDE, the RStudio. You can also run the code in the Jupyter Notebook. Probably you're familiar with it. Here's just another example. You might find this example if you go to our web page and search for API examples. Here it's also another visualization kind of genome browser, which you can reconstruct inside the cell of your Jupyter Notebook, or you can construct it also in R here, and then export as an image or as PDF for your research. You can also do some interesting things like here. First of all, this is again Jupyter, and as you can see, this is actually Python script. So as you can see, I used py-by-uml package, which basically has the same logic. So you can find documentation, this py-by-uml package, download it, install, very similarly to how I did with the R. The logic is the same to log in and then to run maybe some workflows with the pretty much same commands. So we also have this notebooks available for a reference if you want to use it in Python. And here we actually, what we did from this script, we run the site escape library to create some this dynamic visualizations to create some graphs that can be manipulated in real time. So again, this graph was constructed on the basis of the analysis of finding gene regulation with the geneXplain. We'll go and read about our APIs. You can find this these Jupyters. Now I'm just showing it as to see what else you can do. Just to wrap up quickly about the Java, we also have the Java documentation, and you will need to download the package locally with the it will also available from the GitHub. And just to show it, I will quickly go to the terminal and okay. And I have this package installed on my computer. Oh, I think it's just geneXplain API. So this is a Java package, which you can build on your computer. And then there is actually a jar executable. So if I will, which also gives access to, which can be run as a like command line tool, as a command line program. So this jar file I have in my, okay, so I will need to use Java jar to execute. It's the, oops. Okay, so I have this geneXplain API jar. And if you run it with Java installed on your computer, you see that it's actually, okay, it's actually just like a command which you can use in your terminal. So with the with some like you can do regulator search right away, or you can run some apps. So if let's see what apps are available. So just to show that we have like a lot of options to choose from, like depending on programming language is more interesting for you. Oh, I can go to examples maybe. So the package has the documentation. If you go there and if you go to tutorial, you will find some already prepared JSON files. So in this case, this command line application is used with the JSON file in which your analysis is described. So let's see, like we can open any. Okay, so I have it in my geneXplain API in docs and tutorial, and I have several JSONs. If you open them, okay, here just
simple. Yeah.
some definition of the server, and then you have some task lists. If you open it, there are okay, so it loads some tasks from here. You can define like some scripts to run, also to run some platform analysis. So in the same way we defined parameters here in R for a workflow, in the same way you will define your parameters inside the JSON file, and then use this JSON to as a parameter for your Java executable. I will just show maybe one quick example. So we want to, because now I'm in another folder, I'm just running the jar with exec. So exec command for executing tasks configured in JSON file, in some JSON file, let's say hello world. So this is like the most the easiest
Bingo, it
example
says hello
here.
world.
Yes, it says hello world. If you run, like you see here examples on how to import, export files. So you just define them. Okay, the commands. Yeah,
All right. So yeah, we have a lot of
yeah.
possibilities. So I have a question
yes.
to you.
So you see here. Okay, just so here
okay,
just example of
right.
the parameters. So you just in the same way you define the workflow, define the inputs, and then run this command with the given JSON. So this is just another way of using API, geneXplain API, if you want to use it as a command line tool, not inside some script. So so yeah, Alexander, you had a question.
All right. Yes. Just yeah. Thank you for this very extensive. Yeah. Even I can now program, I hope, with a very detailed explanation from you. Thank you very much, and I hope it was very helpful. And if you have any questions, just put them in Q&A. But in meantime, I want to ask questions. So obviously, what you showed today is like how to extend possibilities of the data analysis which we have in platforms. So basically, once I have an account in a platform, as I have, I can do many things, not only just things which you showed today, not only finding differentially expressed genes, which I can do from the interface, but also very specific, things. But then you showed how to extend it. So, for instance, to make a new, very nice visualization of a data which we don't have in the platform, but it is present in Bioconductor, in all other libraries. And basically, you just extend with this parameter, with these R scripts or with other tools, you extend possibilities of the platform. That's clear, but my question is, how does it work other way around? So if there's a user who was always working with R all his life, or just started to work, and he has all these nice libraries, R scripts, and all these bioconductor. So he's analyzing data and pretty happy. But what actually gives him the access to the platform? So why why this user would need to access the platform through the API? What is your answer to that?
Okay, so yeah, so in spite of the fact that yeah, R already comes with a very useful libraries, as we mentioned, Bioconductor, which has extensive number of tools. The GeneXplain platform has a lot of advantages. First, being connected to to the databases already. So you are not only, you have access to both analysis and databases, which you don't need to also like additionally connect somehow. So you have this toolbox which has already everything. So you don't need to try to to also connect to some database to download a lot of data. So once you have your own data inside the platform, you already have access to a lot of databases there with which you can, which gives a lot of additional information, right? Also, the other thing is that we have a lot of like things like maybe upstream analysis, which is also our analysis, so our own algorithms, which you might want to use in your analysis, and comes only with our platform, like with our geneXplain tools. So this very specific workflows, access to the databases that are already like built inside the tool. Also, another thing is that, yes, even if you're a very experienced programmer, like for me still, I sometimes find it more useful to use platform because like I showed the extensive list of formats that are supported by the platform, right? So if you're working with a new data format or with or with some formats, it might take some time for you to figure out like how to actually deal with this format, how to correctly read it. Sometimes some specific packages are needed for that. Like using it in uploading to the platform, which already knows how to work with a lot of data types, can already accelerate the process even for very, very experienced user. The same way with the tools. So instead of using, again, like many tools, and this is the beauty of geneXplain platform, because there are some tools which are just like wrapped in a nice interface in the platform, right? But again, like trying to use it on its own separately, it's again like you need to go to read documentation to figure out how to work with it when you already have a nice interface with just like two main JX workflow and JX analysis, which already has like standardized way of how you access and work with these commands. You don't need to think about like what are parameters of a specific like third-party tool or something. So you just go, it's like very convenient even for experienced user.
All right, right. Yeah, actually, I know that. In fact, that's right. I'm installing R on my computer, and I always stuck with some libraries which I'm missing or databases which I'm missing, and I'm kind of surrender. But if it's already pre-installed in the platform, you just run the command, and it's over there. So the results are there at your fingertips. All right. So that's I guess that's something maybe useful. What our beloved users will reply to that. So if you have any questions, just to put them in Q&A, and we'll be happy to answer them. Right. So in the meantime, right. So just maybe just to summarize, maybe you can summarize about this API, and maybe we can wait for other questions.
So for what I wanted to show and demonstrate today is that first of all, you can really, like, there are a lot of ways in which you can interact with our platform. So not just web interface, but also via different tools, like with the R package, with the Python package, with the commands tool. So we are trying to give our users as many opportunities, as many ways as they can do the analysis as we can. And also, yeah, so you can this is a good using APIs, maybe like a very good way to enhance your analysis and enhance all your like your research skills. So dealing, especially like in bioinformatics and in biological data today, when we are dealing with huge amounts of data, having programming skills is a very good advantage, is a very good like advantageous thing, right? To not only be able to use already prepared tools, although they can be very good in the geneXplain platform, but still like having like accelerating things, automating things, that also like saves a lot of time for you, not to just like spend a lot of time to do some things, some operational things like cleaning your data, uploading data, like all these things. They can be automated quite easily, and that's why like APIs were created. That's why we have our platform to try for the researchers and for the scientists to maybe spend less time figuring out all these operational things and focus more on the results, on what actually data gives you, what insights you might have to actually be like more focused on the scientific, innovative side of your research, rather than like spending a lot of time doing doing these manual things. So that's why we very much encourage our users to try API, even if it's a new thing, even if you're maybe not very comfortable with programming yet. This might be a good way to start also, because you don't need like a lot of skills for that. That might be actually a good start. So for that, we are constantly trying improving our APIs and the and also the features we have in the platform. So with that specific like the thought for you to just have nice tools for you for your research.
All right. So there is a question from Kanika. Does the documentation provide details on the commands to be used on the Linux system?
Yeah. So as I showed, I could show again. So if you're using Linux and you want to maybe just work in terminal in Bash, right? Then a very like maybe you will go with this jar executable API. So with this option here, and this can be just downloaded into your Linux system, and you can execute it right from the command line. We have you can go to this page, or to genexplain.com, to this page with the whole API description, and you will have here the documentation. You have some samples to look at, and also here's the link to download it. So yeah, so probably you can start from this page, and then you'll find all the documentation and all the examples.
Exactly. So, and if you have more questions, just ask Kamilya by email, and I think we will be happy to answer. Thanks you, Kamilya, for presenting this Very nice example and very detailed explanation how to use API. As I said, I'm just ready to use it myself.
Thank you very much.
Thanks a lot and see you next time.
Bye.
Goodbye.